Mais uma vez, boa tarde a todos. Eu sou Adriana Bittar e, em nome da ABM, dou as boas-vindas a vocês. E esse é um dos momentos mais esperados da ABM Week, a Plenária de Mineração e Metalurgia. Em um mundo onde a tecnologia avança a passos largos, o setor de mineração e metalurgia encontra-se em um momento decisivo. A transformação digital já é uma realidade que está remodelando as operações estratégicas e, fundamentalmente, o futuro. A plenária de hoje foi cuidadosamente pensada para ser um espaço de debate e reflexão sobre as tendências e cenários futuros dessa revolução tecnológica. Vamos debater, refletir sobre inovação, sustentabilidade e como elevar a produtividade a novos patamares. Como as empresas podem se adaptar e manter a competitividade e relevância em um cenário em constante evolução. Líderes e especialistas do setor abordarão uma visão estratégica sobre o impacto dessas mudanças nas empresas e no mercado. Que tenhamos um evento repleto de insights valiosos e debates construtivos. Por falar nisso, eu convido vocês a participarem deste nosso debate, enviando perguntas por escrito. A nossa equipe passará recolhendo as perguntas na plateia, então, ao longo das apresentações, vocês já podem ir fazendo as suas anotações, não precisam esperar até o final, e qualquer dúvida, ou se precisarem de papel e caneta, é só levantar a mão que nós vamos até você. Dando continuidade, então, vamos formar a nossa mesa para debater sobre transformação digital como estratégia para inovação, sustentabilidade e competitividade. Eu convido ao palco, com muita satisfação, primeiramente o nosso moderador, Wilson Alexandre Messias Rodrigues, gerente-geral de performance industrial na Gerdau. Vamos recebê-lo com uma salva de palmas. E agora vou chamar os nossos palestrantes, Enrico Plazonha, vice-presidente da Daniele Automation. Vamos recebê-lo com aplausos. Seguimos com Kurt Herzog, Head Global de Indústria 4.0 da Prime Metals. E Tiago Maia, vice-presidente de Soluções X da SMS Group. Uma salva de palmas para todos os nossos convidados. Fiquem à vontade. Então, para contextualizar o tema e dar início ao painel, eu passo a palavra ao moderador do debate, Wilson Alexandre Messias Rodrigues, gerente-geral de performance industrial na Gerdau.
Muito obrigado. Obrigado. Boa tarde a todos e a todas. É uma honra e um prazer imenso estar aqui compondo essa sessão. Muito obrigado a todos os presentes. Muito obrigado aos meus colegas aqui da plenária. Thank you very much for being here today. A indústria, de modo geral, e especialmente a indústria do aço, vivencia uma crescente demanda e necessidade por maior eficiência e sustentabilidade, frente a um ambiente cada vez mais competitivo. Esse desafio, a gente vive e sabe muito bem disso, é ainda mais urgente no Brasil, onde enfrentamos dificuldades estruturais, de competitividade, custos elevados e além de um importante desafio no que tange atualização tecnológica e integração tecnológica. É precisamente nesse contexto que a transformação digital se torna parte desse caminho estratégico e deve ser parte intrínseca da equação que vai nos direcionar para um ambiente e para um caminho ainda mais produtivo, competitivo e sustentável. Eu discutia previamente aqui com meus colegas que é fundamental que a gente entenda que a tecnologia em si, ela não é o fim, mas ela é uma alavanca, um habilitador que, quando bem compreendido e conectado aos desafios reais de negócio, tem o potencial de destravar e habilitar capturas e diferenciais competitivos reais, né? Isso torna, e é por esse motivo que a discussão de hoje é tão relevante, como a gente pode tocar e tangenciar os temas de tecnologia e a transformação, traduzindo esse movimento em um real diferencial competitivo. Para conduzir e nos guiar hoje nessa reflexão, os colegas vão compartilhar um pouco da visão, das experiências e do que a gente tem visto rodando mundo afora. Enrico, can you start, please?
Boa tarde. And this is the only Portuguese word that I can say, so sorry about that. I apologize to all of you. I hope you will understand anyhow my speech. So, during yesterday's panel, very interesting panel, the most reputable steel makers here in Brazil were all, let's say, complaining about difficult times. So everybody was complaining about China, about Trump, about the situation we are facing. So what are we going to do? These things are not changing by themselves. So I think that digital transformation can be a possible answer to that. Making the plants, as the title of this conference, innovating the plant, making it more sustainable and competitive. This is a possibility, and this is what we are also trying to do, because we have the same problems in Europe. We have the same problems everywhere in the world, actually. All the world is moving. So I would start with the word of hope. We have possible solutions ahead. Considering that this is a panel, I didn't want to make a, let's say, traditional presentation, marketing presentation. I just wanted to show you what we are doing. And to do that, we start from the concept of single pulpit. Why single pulpit? Single pulpit is a nice idea. I can have less operators controlling the complete plant. But behind this idea, we need to insert a lot of technology, a lot of solutions, a lot of different approach to steel making, which I will show you we started doing many years ago. So when we speak of single pulpit, we are not speaking only of centralizing all the controls in one place. We are speaking of increasing the level of automation of a plant. Look at the steel plants and look at a car factory. A car factory is fully automatic. A steel plant is fully manual. So there is a lot we can do. Then there are automation, yes, but also we have to think about cameras in the plant. We need to think about machine vision. We need to think about robotics, automatic yards. So you see, a single pulpit is increasing safety, is increasing efficiency in operation, but you need to do a lot of things to make it real. I will show you some of the steps we've been doing in time. So we start from this. This is a very old picture. This is 2012, Riva, Marcinelle in Europe. This is a plant where the melt shop was already there, and we did only the revamping of the automation of the plant, centralizing the control for electrical furnace, charging crane, and ladle furnace in one single pulpit, as you can see from this small video. Yes. So imagine this is 13 years ago. And the idea is, you see, cameras to show what happens. The idea is to have even the crane controlled from the pulpit. So, and this is basically done with automation and robotics in this case. Nothing so fancy. I repeat, this plant was existing. It was just a revamping of the existing plant. And I can also tell you that thanks to this intervention, it was something contractual. We could increase the efficiency and the production of the plant of 12%, just by working on the automation and doing this single pulpit. Why that? Because we could decrease the delays, we could decrease the unexpected stoppages, we could decrease all those things which sometimes are an issue in a real plant. Now let's move ahead. Things are evolving in time. This is 2020, yeah. This is actually a wire rod mill. It's a plant which is controlled by Danieli. It's our own plant. And we wanted to make a plant which was state-of-the-art, controlled from a single pulpit, but we added something very important here. We added a concept, a vision. This plant not only has to be controlled from a single pulpit, this plant must change the way operators are working in a steel plant, in this case a rolling mill. This plant is producing 500,000 tons of quality wire rod in very small lots. So the target here was the ability to do first-time good, to have a very frequent shift, very frequent change, and to do this in a very efficient way, because every stop is losing money, is losing time. So the system has been designed, first of all, using also the competence of university professors working with Airbus to design the simulators and the cockpit of the airplanes. The concept is the same. Here we have a plant which is working in a fully automatic mode. The operators are there to manage the anomalies, the issues, like the airplane pilots, the same concept. And to do that, we had to design a system, first of all, collecting all the information, all the variables of the plant, and here it comes with digital transformation. We are speaking of a data-driven plant. We collect all the data, all the images, all the parameters from the plant. This information is kept for analysis of anomalies, for analysis of issues, and the target we have for the future is to make a plant which is learning by itself. When something is wrong, the plant is taking all the information and is, with the help of the operators, of course, learning how to get better, let's say, how to avoid such issues. And the plant is event-driven. So I give you an example. I have an out of tolerance, and immediately an image pop-ups in front of the operators with the images from the profile gauge, showing which is the out of tolerance. And even the plant so can be designed also to add all these, let's say, event solutions. When something happens, the operators are issued. Now we are designing the same solution for the melt shop. Again, we have the idea to have a single pulpit from scrapyard to billet yard. So imagine you have a pulpit where you can control the automatic billet yard, because we want to make it, automatic scrap yard. So having the cranes moving autonomously to the position and charging autonomously the buckets or the belt, whatever it is. And down to the billet yard, where the billets are handled automatically. So all these things are possible, are already happening. I think yesterday also Ternium was present here. In Ternium Pescheria, we have a slab yard, which was developed thanks also to Ternium Pescheria, of course. We have a slab yard which is fully automatic. There are no operators on the cranes. Everything is controlled from a pulpit in remote mode with 4 or 5 operators, I don't know exactly. There are 11 cranes and a number of transfer cars, all controlled automatically. Train is arriving, discharged automatically to the place, and everything is unmanned. So this is the future we can build to reduce the cost of operation, to increase the efficiency of the steel plants. Another example, this is an example of a MIDA technology, endless casting and rolling, Danieli. One of our MIDAs in the US. We have more than 25, I think now, plants in operation worldwide, where, again, even here, we are reducing the cost of operation. We have a plant without a rating furnace. It's a greener plant. It's a more efficient plant. We can save up to $60 per ton. This is the way to fight against, let's say, the difficult times we are facing. And again, a pulpit, a centralized pulpit to overview the entire plant. Okay, we are working, we are Italians, of course. We work also on, we like beautiful things. So we have designed even a pulpit, a liftable pulpit. So, but this is a good excuse to tell you one important thing about these pulpits. It's very important to attract talents to the world of steelmaking. This is one of the problems we have here in Brazil, but we have the same problem in Europe. So imagine working in a steel plant, maybe also now, but certainly 20 years ago, a place that my son probably would not like to go to a steel plant. But if you give them a nice place, like a video game, where they can control the entire plant from one pulpit, maybe things can be different. And it's unbelievable the quantity, the level of technology that today we are injecting in our technology. What we are doing today with the AI, with the automation, with the machine vision, is really of a very high level. There are not so many technologies, not many technologies worldwide which are using so much what is available on the market today. Finally, I show you an example for flat products. And again, it's an example of a single pulpit. In this case, the pulpit is not yet in the plant. In this case, the pulpit is installed in our workshop in Danieli. This is a factory acceptance test. So imagine that we have installed the complete plant, the complete automation system of the plant, the complete pulpit and the servers, whatever, to test the software. Not only that, but we also do some simulation of the plant, some process modeling, so that operators can really operate in a situation similar to the real plant. We can test the software on the model. We can then, in the future, give the customers and also to our team a tool to simulate the process and to improve the process. So this is what we are working on, including the quality control, of course. In the technologies that we are, let's say, pursuing, that we are pushing as Danieli, the endless casting and rolling technology, there is no possibility to take a sample and correct the chemistry. Once you are in the caster, you have to roll it. So we need to simulate the process to understand what we are rolling, what is coming out of the caster. So this is why we are pushed by technology to improve our process knowledge, our process control, our modelization. It's a challenge, as I told you. It makes things more complicated and makes things maybe more depending on the automation in the plants of the future. But this is what is actually happening in the life of all of us today. Our cars are not mechanical cars anymore. They depend very much on the software. And I believe that it's happening also for steel industry, if you want steel industry to be competitive and up to date. Thank you very much.
Thank you, Enrico. Kurt, please.
Good afternoon, ladies and gentlemen. The question of this session is digital transformation solving your problems of the future? And I would like to use the words of the question to give you the answer. I think that transformation is solving the problems of the future. And digital provides the tool set to do this transformation. And when we talk about digital these days, there's no way out to talk about artificial intelligence, AI. And in my presentation, I will talk a little bit about what is necessary to efficiently use AI in a production environment. I'm very happy to be here. I think it's the 5th or 6th time, and I've seen this ABM week growing, and congratulations. Unfortunately, my Portuguese is not yet good enough, so I have to give the presentation in English. There is translation, a task that in future maybe will be done by AI. AI is very good in translating languages, especially when it comes to European languages. The reason is very simple. You know what data set is used to train language translation models? The European laws, the laws of the European Union. There is lots of laws in the European Union, and they are all translated in all European languages by professionals. So if you want to, and there is no copyright, so they are accessible. So if you want to train an AI model, you have a perfect training data set. And that brings me, when we talk about AI, to the foundation of AI, and that's data. And it's all about data, but it's not only about data. We all know this one. That was too fast. We all know this one. Data is the new oil. It's a very old one. Some say that the world's most valuable resource is data. Maybe we do not all agree on that. I think that high-grade iron ore is a very valuable resource as well. Then, Carla Fiorina, former CEO of Hewlett Packard, she said, it's not about data, we have to extract the information and generate insights out of the data. Okay? So we don't only have data, we increase our knowledge using data. I particularly like this one. It's very old. It's from Mark Twain. And he said, data is like garbage. You better know what to do with it before you start collecting it. But the one I like most is from a person that is not that famous. Few people in the steel industry know him. It's from Günther Brumbauer. He is currently head of iron and steel making of First Alpine, Austrian steel producer. And he's a pioneer in expert systems. At First Alpine, the first expert system in closed loop operation was installed when no one was talking about AI, about more than 20 years ago. What Günther always said is, data and information without action is useless. And what does it mean? Dali Fiorina said we have to extract information, but if I don't act on the information, nothing changes. So, if we want to make data effective, what is necessary? And I've set up a little simple formula here, saying the effectiveness of data is the quality of data multiplied with the quality of applied know-how and the degree I'm acting on that. So if I have all the data in excellent quality and I know everything, but I don't start acting, nothing changes. There is no effectiveness of data. So let's have a look at the individual factors of this formula. When we talk about quality of data, steel industry is very special. Why? The data structure and the data characteristics in the steel industry is different than in many other areas. We all know use cases from the B2C business where on internet platforms where you can buy things like in Amazon or so, they do a lot of data analysis to analyze the behavior of the customer and continuously improve their offering. And the data they are working with is basically the order data of their customers. This is one transaction with, I don't know, maybe 30 data points. And all those 30 values are correct, so they don't have data error. They have a huge number of these orders, so they have a huge number of records that are independent from each other. Number of data points is limited, as I said. And the data structure is very simple. If you look to the steel industry, data in the production at least mainly comes from measuring instruments, and we all know there's no measurement without failure, so we have error in the data, and we need to consider that. We do not have that high number of independent data sets, but we have a huge number of data points, and I will come up with an example later on. If you want to analyze the quality of a flat product, it's about 10,000 data points from the melt shop to the finished product you need to consider. And we have extremely complex data structures. So there is lots of automation systems that are all, from a data perspective, optimized in a sense that the data structures they used are optimized for their functionality. And this data structure needs to be cleaned up, otherwise you cannot use the data efficiently. So when we talk about quality of data, we need to consider a few dimensions. The data needs to be complete, should be there in time. If I want to react in more or less real time, the information should be relevant, accurate, and consistent. Talking to data analysts, they say 80% of their time they spend on preparing data, and 20% they do data analysis, and I'm pretty sure it's even worse. Knowledge. We have to digitize knowledge. The interpretation of the data needs to be automated. We need to bring the expertise into the systems. Like Enrico said, there is a lot of operational expertise in his one-man operation pulpit. Why is it necessary? First, we don't have this many talents, and on the other hand, we need to have consistent operation. And the system always takes the same decision. People have own opinions and take different decisions. So, there is lots of different forms of know-how. We need to find ways to integrate these different forms of know-how. But the nice thing is we can use that for continuous learning because we have consistent decisions. And that's always the starting point. Maybe the best operator you have makes better decisions than the automation system. Bring this know-how into the system, then the best operator is on site 24/7 and you can even improve. And one factor that is very important is we need to take the operators on this journey. So these decisions need to be transparent and traceable for humans, for the responsible people. If the system makes decisions and operators don't understand what's going on, they will switch off the system. Very easy. And then degree of action. Action these days is taken by automation systems and actuators. So we need to integrate the AI into our automation architecture, into our automation landscape. This is the traditional way. There is sensors that provide data. This is somehow transferred into information by models, maybe data-driven models. And then an operator who was trained by a process engineer gets this information, makes a decision, takes an action. Now we bring this digitized knowledge base, this digitized know-how that interprets the data and makes decisions into this loop, and have closed loop control systems where decisions are made based on digitized know-how. And we can use the data to learn and improve the process, improve the knowledge base, improve our prediction models, and all that with all the AI and data analytics tools that are available. And by doing that, you can increase the autonomous operation of your plant with the right side of this picture, and you can support the continuous learning process with the left side of the picture, and all the digital AI tools we have can be integrated here. The nice thing here is that there is still humans in the loop, but their role has changed. Now, people are making decisions. In future, the people will define how decisions will be made, but the execution of the decision is automated. Brought some examples with me where we use different kinds of AI or different kinds of digital technologies in smaller and maybe not that small solutions in the production process. And that starts with, we call it artificial ear. Old maintenance engineers were walking through the plant, they heard a noise and they know what's going on and they know that there is a problem. We can do the same with microphones and AI models that identify problems in the plant, give an alarm and make sure that problems or support that problems are fixed before they get serious. Same we can do, like not only the ear but with the eye. Camera streams can be analyzed if there is problems, like in the example here. If the trimmed tailhead of the strip does not fall into the bucket, but is stuck somewhere in the plant, an alarm is automatically generated to avoid that there is a problem with the next strip. This is rather small solutions, but very important to support this one-man operation topics, because this takes load from the operator. The operator only needs to involve himself if there is a problem. Why should he look at the shear if there is no problem there? So why present this information, this camera stream to the operator if everything is okay? So this kind of assistance systems are necessary to come up to this kind of, we call it central operation cockpit, support operators that one operator can control an entire plant. Another use case, many of the steel producers use scrap, and they order certain kinds of scrap, and they have models that calculate what scrap should be used for the next heat, and then they charge the buckets on the scrap yard, but we all know what's in the bucket is not what should be in the bucket. And many different qualities need to be produced, and the good operators know what to do. And what we're doing with this system is we analyze the operating procedures, the melting practices, depending on the scrap mix that is put into the furnace and the target chemistry of the melt to analyze what is the best melting practice for a certain scrap mix to produce a certain steel grade. And with learning that out of the historic data, we can bring these melting practices into our process optimization system, and that guides the operator through the melting process. That means that the operator does not make decisions, but is guided because there is a model in the background that calculates the best melting practice for him. And this eliminates the human factor. And if you analyze the data, by the way, the login number of the operator is one of the most decisive factor, the most decisive parameter when it comes to is this a good or a not so good heat. By eliminating this factor, efficiency can be dramatically improved. Prediction of silicon and temperature, tapping temperature on a blast furnace is one of the big topics, and there is presentations on each and every conference. We've solved this problem with machine learning, but we don't only predict the temperature and the silicon content. We add additional information. Additional information means we built an explainable AI that not only tells you this is the prediction value, it also gives a confidence interval. How confident is the model that the prediction is correct? And it explains what are the main driving parameters, why the model came to its conclusion. So it explains to the operator, this will be the tapping temperature, and I'm 95% sure that this is correct, and the reason is this and that. This gives trust to the operator, and then we can automate the decision because the operator sees, okay, the prognosis is reasonable, and the decision is correct, so we can automate the decision, we can use this in an expert system. By the way, that has been installed on a blast furnace, tested and installed on a blast furnace in Brazil. And last not least, the biggest application is our through process quality control system, where we collect quality relevant production parameters and process parameters along the entire production chain, from the desulfurization to the galvanizing and processing lines. 16 aggregates on 2 production sites. We integrate 6 surface inspection systems, and in total we collect 8,000 process parameters. Huge amount of data, and this is an excellent foundation. It's a lot of work to bring the data of all those diverse automation systems in a unified, usable shape. The bad news is there is no way around. This work needs to be done. But if you have your data in a proper order, in a proper structure, you can do a lot of things. And the functions we have implemented here is automatic grading. If there is deviations, automated root cause analysis. Why did it come to these deviations? Feed-forward compensation means if there is a problem on an aggregate, what are the best production parameters on the next aggregate to fix the problem? Statistic process control, KPI calculation, and property prediction. Excuse me. So this is what's the functionality that is running 24/7 in operation. When it comes to learning, I would like to show you the next slide. Here it is. Our customer wanted to produce a new steel grade where he had no experience how to produce it, and he started to test heats, test batches, and produced about 500 coils. And he had an issue with a huge fluctuation of the tensile strength. So we had all the data of those 500 coils in place, 8,000 parameters along the entire production chain. And we could now use data analytics tools to find out what are the most important parameters in the chain and which are the right values for those parameters. And the cool thing is, having all the data in the system structured properly, it took our data analysts 7 hours to come up with results. So the bad news is there is a lot of work to prepare your data properly, but when you've done your homework, you can do very, very, very important things in a very short time. And you can imagine what that means when it comes to product development and time to market. So, to summarize, quality of data must be good. This is essential. This is the foundation. There is, for almost each and every kind of problem, some AI methodology or technology that can support. You have to choose the right one. That's important. You cannot do condition monitoring with a large language model. It's the wrong technology. But there is good technologies to do condition monitoring. If you want to make your data effective, you have to make sure that it's implemented properly in your automation landscape, that really actions are taken. And this is maybe the most important point, you have to take your operators, your people on this journey. You have to build transparent systems that people are willing to work with them. And on my last slide, just to wrap up what we as Primetals combine to build efficient AI applications. It needs domain know-how. When you do data analysis, it's better to understand what you're looking for. For sure, it needs people, the number crunchers, with the mathematical and statistical know-how and the data analysis know-how. This can help you to find issues, but to integrate into the automation landscape and come up with robust applications that are suitable for production. We are talking about production here. It also needs excellent programming and IT skills, and this is what we combine to build our AI solutions to support the steel industry to be more successful in future. Thank you very much.
Thank you, Kurt. Thiago?
Boa noite. Funciona? Boa noite, pessoal. Sou o Thiago, sou responsável pela área de soluções da SMS, baseado na Alemanha. Só uma pequena palavra para conectar, onde nós entregamos para os nossos clientes tudo o que eles precisam para operar. Não apenas o equipamento no início, mas todos os serviços, todo o suporte de digital, todo o suporte de automação, que é o que nos traz aqui hoje. Nós temos 5.000 pessoas no mundo todo nessa área de soluções, 2.000 das quais trabalham com software e estão diretamente envolvidas com esse processo de digitalização da indústria do aço e de metais. Todos nós já vimos isso aqui antes, né? É a famosa curva de hype. Então, toda vez que uma nova tecnologia chega, todo mundo se excita, todo mundo consegue justificar um orçamento adicional para fazer um projeto piloto. Fala-se muito sobre aquilo até todos descobrirem que os retornos não são exatamente aqueles que tinham sido antecipados. Então, esse é o clássico. Hoje, fala-se muito sobre AI, que é o meu tema hoje. Eu vou falar um pouquinho de AI e o que a gente tem percebido na SMS. Mas já tem uma primeira brincadeira ali, né? Que é AI isso, AI aquilo. Dizem que AI é o novo bacon, né? Coloquem AI qualquer coisa que vai ficar melhor. E, de fato, a gente tem visto isso. Entretanto, depois da curva do hype, a gente também tem uma outra curva difícil, que é o famoso hockey stick de trazer os retornos sobre aqueles investimentos. Então, não é um processo rápido, é um processo lento, é um processo que requer continuar investindo, requer resiliência, mas, eventualmente, depois de muita pancada no final, algumas dessas tecnologias, de fato, mudam a forma como nós trabalhamos. Eu acredito, e nós na SMS acreditamos, que nós estamos passando por um momento como esse. Tem uma pergunta que várias pessoas me fazem, eu tenho essa resposta já até há algum tempo. Qual que é o futuro da digitalização para a indústria de metais? Só para introduzir o tópico. Para mim, são duas grandes tendências. Primeiro, cada vez mais nós estamos vendo as aplicações de digitalização, de controle de automação e toda, inclusive, essa convergência entre automação e digitalização ficando cada vez mais profundas, tocando cada vez com mais precisão o negócio, modelos cada vez mais sofisticados. Nós vamos chegar ao ponto de modelar cada molécula na reação daqui a pouco, se é que já não está lá. Mas isso é claro hoje pela disponibilidade de capacidade de processamento e pela disponibilidade dos próprios métodos de modelagem. Nossos modelos estão ficando cada vez mais precisos e, com isso, a gente tem todo tipo de eficiência interessante. Só que, ao mesmo tempo, além de ficar mais preciso, mais sofisticado, nós também estamos ficando mais largos, cobrindo uma área maior da planta. O que quer dizer? Que a gente está cada vez mais conectando áreas que antes estavam conectadas. Isso quer dizer que quando a gente começa uma corrida na aciaria, seja ela de qual tipo for, com um adequado sistema de controle, você já sabe a temperatura que vai ser necessária lá no lingotamento contínuo, fazendo uma análise de risco para cada uma dos passos da metalurgia secundária, até o início do processo, se aquela corrida vai poder ter algum tipo de atraso, se sim, como que eu mitigo isso para diminuir as perdas térmicas ao longo do processo como um todo. Vários exemplos como esse, seja dentro da aciaria, seja na laminação de planos até de longos, estão cada vez mais presentes. Nós recebemos aqui, parabéns para o pessoal da Térnio, um exemplo muito legal, ontem, um dos artigos premiados, onde toda a modelagem de fluxos energéticos, de gases, combustíveis de toda a planta foi feita com previsibilidade, com análise preditiva, de novo, de ponta a ponta, numa planta inteira, modelando dezenas de equipamentos. Então, só um exemplo de onde a tecnologia tem ido. E os retornos, né, que vêm daí, de produtividade, de redução de custo e tudo mais. Mas não era esse o ponto principal. Nós já estamos aqui, só que agora tem essa história de AI. E aí, para onde a gente vai? E de fato, não é só porque a gente é do ramo, mas a gente tem visto a tecnologia permear a forma com que todo mundo opera e a forma como nós ofertamos tecnologia também. Então, tem alguns pontos. Primeiro, novos modelos de AI vão continuar ficando cada vez mais profundos, vão ficar cada vez mais precisos. Mas, além dos modelos especialistas, o que a gente tem visto é que modelos generalistas, e talvez o maior expoente é que todo mundo está na boca do povo, né? As LLMs, ChatGPT e tudo mais, eles estão chegando cada vez mais dentro do cotidiano de todas as empresas, inclusive das empresas de aço. E a gente tem começado a ver um processo interessante, que AI está se tornando um motor de acelerar o processo de digitalização. Por quê? Porque fica mais fácil. Eu vou mostrar um pouquinho isso aqui. Programar, né? Vou fazer uma grande simplificação aqui, sem nenhum rigor técnico, mas só para construir um argumento. Programar, né? Mandar instruções para um microprocessador executar aquilo que a gente quer. As instruções, elas são todas em binário, essa coisa feia aí. E pouquíssimo tempo depois, nós começamos a usar linguagens de baixíssimo nível para fazer essa interface com o hardware. Quem conseguia fazer isso? Só os engenheiros extremamente especializados, extremamente pouco produtivos, difícil de ser feito. pouquíssimo tempo depois, década de 50, 60, consolidando, e é o que a gente usa até hoje, as chamadas linguagens de alto nível. Então, a linguagem de programação, onde alguém consegue redigir um programa, um compilador manda as instruções, ou transforma isso em instruções para o processador. Isso, todos aqui já devem ter visto isso. A turma da área, obviamente, faz isso muito bem, mas várias outras pessoas já conseguem fazer isso também. Engenheiros conseguem fazer isso, seja isso de vários pontos. Quantos engenheiros a gente não tem no nosso próprio time que não tem necessariamente essa formação técnica, mas sabem fazer análise de dados em Python e outras linguagens? Então, mas aí, obviamente, vem o próximo passo. O que muda? É porque agora, ao invés de falar uma linguagem intermediária ou até uma linguagem da máquina, a gente consegue programar os computadores com a nossa própria linguagem. Então, a barreira de adoção caiu drasticamente, e tem caído drasticamente. Hoje, esse tipo de tecnologia está acessível para todos e vai ficar cada vez mais fácil. Então, é comum ver, até hoje, ou até muito recentemente, se você tem um especialista de processo, seja ele quem for, querendo resolver um problema, seja ele qual for, eficiência energética de um forno elétrico a arco, problema de planejamento da produção. Você tem uma pessoa que entende do problema, 10 nerds, né? Eu vou tomar a liberdade de falar, porque eu me identifico com eles, para suportar aquilo ali, do ponto de vista de desenvolvimento de software, de fazer o computador atender os requisitos que aquela única pessoa tem. Os nossos projetos todos, até agora, nessas últimas décadas todas, funcionam com essa desproporção. São poucos especialistas de negócio, nas áreas são os engenheiros de processo, são os gestores, dependendo de qual área a gente está tratando, e um monte de gente para fazer aquilo funcionar, para testar, para depois manter funcionando. O que a gente tem visto é que tem ficado cada vez mais fácil para cada um deles serem autossuficientes. E nós eliminamos o pessoal de tecnologia, os tecnologistas? Não. Mas nós estamos entrando num momento onde um número muito menor de gente de tecnologia consegue suportar um número muito maior de especialistas de domínio, de processo, porque eles conseguem usar este tipo de interface que, insisto, nós estamos no começo de uma jornada que vai ficar cada vez mais fácil para que todo mundo consiga fazer o desenvolvimento das suas próprias aplicações, que, em outros termos, é fazer o computador fazer o que você precisa. Só que tem outras mudanças, né? O que é um projeto de software, normalmente? A gente tem algumas pessoas sênior, é quem sabe o que está fazendo. A gente tem uma camada intermediária, plenos, é quem enche a laje, né? O pessoal brinca, é quem faz boa parte do trabalho. E a gente tem um monte de pessoas mais júniores fazendo trabalhos mais operacionais que precisam ser feitos. Então, são as chamadas pirâmides, e é assim que normalmente se compõe um projeto. A gente tem visto uma mudança. Como as atividades mais operacionais estão sendo automatizadas, os times estão começando a se estruturar, não para distribuir trabalho operacional, mas para treinar os próximos sêniors e os próximos plenos, ao longo de uma cadeia. Então, é uma mudança que não só atinge quem está usando a tecnologia, mas atinge os nossos times que provêm essa tecnologia. Então, boa parte do trabalho operacional que hoje é feito por grandes quantidades de pessoas, acho que está diminuindo rápido. Eu estou falando de mais 1 ano, 2 anos, 3 anos, isso ser sensível, inclusive, nas nossas estruturas de custo. Então, hoje, né, a AI, inteligência artificial, ajuda os nossos pessoais. Isso é hoje, final de 2025. Ajuda as nossas equipes a serem mais produtivas, muito mais produtivas, conversando com os colegas aqui de outras empresas, conversando com o pessoal da Veta, que é o nosso braço aqui no Brasil, muito mais produtivas. Hoje, por exemplo, na SMS, não se contrata mais uma pessoa de software se ele não dominar o uso de AI para fazer desenvolvimento. Não faz sentido. É tão mais rápido. Mas hoje o estado que a gente está é que as pessoas mais técnicas conseguem usar e alguns dos nossos engenheiros já conseguem usar também. O pessoal de processo já consegue usar também. Muito em breve, de novo, 1 ano, 2 anos, 3 anos, vai continuar ficando tão mais fácil, tão mais robusto, que os times de tecnologia vão ser voltados para suportar essas infraestruturas, essas plataformas, e o pessoal de processo vai ficar cada vez mais autossuficiente. Claro que vai ter várias aplicações complexas, com algoritmos complexos, com outros requisitos. Ninguém vai perder o emprego, tem muito trabalho para ser feito, inclusive para o pessoal de tecnologia. Mas o que a gente está falando não é isso, é que a escala de adoção, de digitalização, de ter computadores sendo responsáveis e automatizando tarefas que hoje não são automatizadas, está acelerando e vai acelerar cada vez mais. E aí, só para trazer uma última mensagem. Talvez alguns de vocês estejam familiares com o termo Foundation Model, né? Que é o famoso Large Language Model. Language é um Foundation Model, né? Quer dizer que é um modelo grande, de larga escala, com grandes bases de dados para treinamento, tararau, e sabe linguagens. Então, nós fizemos isso bem, né? Essa tecnologia ela evoluiu muito. Por isso, as LLMs falam bem, traduzem bem, redigem texto, sumarizam texto, que é tudo que a gente já conhece. E é por isso que elas sabem programar. Programar é uma linguagem, né? Então, a gente está falando de eu falo para ela na minha linguagem, ela conversa com o processador na linguagem dela. Depois, isso também já está no nosso cotidiano, nós introduzimos outros Foundation Models de imagem e vídeo. É por isso que nós temos, não é só assim, mas é por isso que nós temos várias aplicações fantásticas de visão computacional, em alguns outros casos de geração de vídeo, geração de imagens, é porque existe um Foundation Model para imagem e para vídeo. Também para som. Por isso a gente consegue falar com o computador ou com o celular, e ele entende o que a gente está dizendo e ele também sintetiza a voz. Muito bem, são Foundation Models. A minha provocação para vocês é: o que vai acontecer com os nossos times de engenharia, inclusive para nós, empresas de engenharia, quando os Foundation Models que já existem ficarem mais robustos, mas Foundation Models para diagramas elétricos, diagramas mecânicos, diagramas de instrumentação e de piping, o mesmo impacto que nós temos hoje em relação à produção de texto, produção de imagem, produção de vídeo, vai chegar na engenharia. Da mesma forma, o que vai acontecer com a operação das nossas plantas quando os Foundation Models, que também já existem hoje, ficarem mais robustos para a operação industrial? Então, hoje, essas tecnologias já existem. Então, ao invés dos nossos sistemas de automação e controle, ao invés dos nossos sistemas de nível 3 serem estritamente baseados em regras como eles normalmente são, e terem modelos de AI dedicados, específicos, que são construídos para pontos específicos, a gente está rapidamente chegando no momento onde um modelo generalista consegue entender a operação, consegue se retreinar, consegue responder, consegue raciocinar, reason, sobre aquilo ali. Então, só um último ponto complementando a última apresentação. Nós vamos ter uma planta totalmente automatizada? Sim, claro. Sim. Mas quando? E aí, só lembrando, a gente já tem tecnologia para automatizar várias outras tarefas que já são automatizáveis, né? Mas também existe uma decisão por estar automatizada, mas vamos deixar uma pessoa fazendo a supervisão ali. Mas uma coisa é certa, que nós cada vez mais, e esse é um impacto direto para a operação das nossas empresas, vamos ver as pessoas parando de fazer a operação em si, mas supervisionando. Isso quer dizer, vendo se está tudo indo bem e se as condições de contorno, não só as rotinas, estão adequadas. E principalmente, e aí não é só um trabalho de software, mas com o resto de automação, com o resto de robótica, de tirar as pessoas de situações que hoje não são seguras no chão de fábrica. Então, isso é o que a gente tem visto. Finalizando, Claro, digitalização vai continuar tocando tudo, ainda mais com esse ritmo de adoção acelerado e acelerando, mais profundo, com maior cobertura. Com essa aceleração, hoje, quem é usuário, hoje, os engenheiros de processo, hoje, o resto das equipes todas dentro de uma planta, cada vez mais vão virtualmente se tornar desenvolvedores, vão quebrar a dependência de precisar de uma área inteira com outros especialistas para fazer aquilo que eles precisam, vão conseguir fazer sozinhos. E um ponto principal, dentro daquele hype todo, se a gente olha as tecnologias todas, tem dezenas de tecnologias que entram nas curvas de hype, isso e aquilo, AI é mais uma delas. AI está mudando significativamente a forma como a gente trabalha, tanto do lado operacional, com automatização, quanto do lado de knowledge work, do trabalho que requer acesso à informação, que requer raciocínio, que requer uma sofisticação maior. E, finalmente, sim, isso vai mudar disruptivamente a forma como nós operamos as nossas plantas, mas no nosso ritmo. Né? O nosso ritmo é um pouco mais cauteloso. Então, de uma forma gradativa, nós vamos assistir essa mudança. Mas em breve. Gradativo não quer dizer nos próximos 20 anos, quer dizer nos próximos poucos anos. Pessoal, obrigado.
Thank you, Thiago. Muito obrigado. Now we will have 40 minutes, roughly, to questions. And I would like to start one. I would like to hear from you guys. What do you think that are the critical or the most critical barriers to turn into reality everything that you see and discuss in your presentations?
Shall I? Okay. Well, I can say one thing, then you say the other. I think the most critical part is the company engagement. So the company has to be, plant makers have to be really engaged to adding these new technologies, adding this transformation. If not, there's no way.
I think it's not that much about technology. The technology is there. It is very much about people and the willingness to change. And there is so many fancy use cases out there. We are all impressed. But if you see what's really ending up in productive systems in the production, by far, it's a much smaller number. Why? Not because technology is not capable, because there is resistance in changing processes, working processes, tasks and roles in the operations. And I think that this is something for the management, for the top management. It takes time. It doesn't happen from today to tomorrow. But it has to be continuously driven by the top management, taking all involved people on the journey. Then the technology is there, things will be implemented. I think this is the most important topic. It's not about technology.
Bom, eu vou responder em português. Talvez 2 pontos. Primeiro, a gente tem visto cada vez mais uma nova geração de gerentes mais familiares com as tecnologias. E isso tem feito toda a diferença. Eu acho que cada vez mais o que antes era algo um pouco mais distante começa a ser mainstream, aquilo que todos buscam. Mas, em paralelo, tem um outro processo que talvez explique por que nós temos a reputação de sermos uma indústria que demora a se renovar. Quando nós fazemos o comissionamento de uma nova planta ou de uma nova linha, nós não vamos voltar lá daí a 6 meses para fazer uma modernização. Então, novas plantas e novas linhas já estão sendo comissionadas com tecnologias de ponta. Mas nós vamos voltar lá daqui a alguns anos. Muitos anos em alguns casos. As plantas vão rodar por 10, 20, às vezes mais anos. Talvez em algum momento com uma modernização do lado de automação, mas de qualquer maneira os ciclos são mais longos. Portanto, acho que isso explica um pouco o ritmo da adoção, mas tem um processo natural aí de modernização.
Legal, Thiago. And to connect the last point that you bring to us about the old plants, the brownfield challenge, I'd like to ask you and our colleagues here, what do you think about the challenge when we talk about the brownfield implementation of these technologies?
We do the same. Okay.
You can change the
it's
order, okay?
Well, the main challenge in the brownfield is, of course, you need to act on what you have available, and you need to change what you have available to put it in line with the new technology. So it's something which can be done. It's not a big issue, and also can be done in a relatively, let's say, easy way without a big impact on the daily operation of the plant. We are not speaking of changing a caster turret, or we are speaking of adding an infrastructure which can be installed in parallel and then shifted in a relatively short time. So this is also our experience, and actually is what is happening in many plants.
Surprisingly, I agree. And I think that just imagine you operate one caster and now you get a new one with all the fancy features. So your operating team was trained on the old caster. They are good. They know what they are doing. They know if there is an issue, how to react. And then they are confronted with the new caster that has all those support features. I don't think that they feel comfortable. I think that the brownfield installations open up an opportunity for this continuous change, saying, okay, guys, this is the old system. We'll keep it there. We put something new aside that adds on to the old, that supports you, and we gradually improve it. Put more functionality in, and then they have the chance. They are taken on this journey, on this transformation journey. So I think, and interface-wise, I mean, these topics, fortunately, in the meanwhile, are all solved. So integrating the systems, technically, this is work to be done, but that is solved. And the brownfield projects open up the opportunity to really take the team working with the plant on the journey. They can even bring in their ideas. Okay, we used to do it in this way. Can we somehow change it? If it's a greenfield plant, it's a big bang, and people don't like big bangs.
I'm going to make everybody's lives easier here with English. But then you have to define modernization, right? So if it's a deep modernization where we have to go in and change drives, change the electrics, then that's a little bit more challenging. It's almost like greenfield in terms of how to apply those technologies. However, when we talk about AI, in a lot of applications, as we have been implementing, you go to brownfield, it's easier because the processes are more mature. There is data that's quite relevant. The people are trained. So you have a more stable environment with the history. So you can introduce an optimization like this. So it goes hand in hand. Are you going to do this to a really run down line? You could. The only risk is that you lose that work if you're going to really modernize the equipment. But otherwise, it's actually easier.
Thank you. And connected with that, with the use of AI, one question here, it's about the use of AI agents in manufacturing environment. What do you think about that? Far from reality, what do you think?
No, It's technology-wise, it's not far from reality. But first things first. And as I said in my presentation, we have to come up with a proper data environment. Agents can be built. There is use cases where agents make sense. This is from an IT perspective. The technology is there, it can be solved. I'm not sure if the foundation is there everywhere.
Yeah, I think some of this we already do, we just don't call it that. Because in other domains, if you talk about agentic AI, you're talking about agents that learn from each other, compete with each other, usually at larger quantities, which is not the problems that we have. But we do have logic, automation, AI, dedicated models on each one of the process steps, and they talk to each other. So we don't brand it agentic, not yet, maybe, but this interconnection that we have within the steelmaking environment already takes place. And the learning, which may be the trickiest part, I think this is steadily growing. Today it's shy. I think we all have some examples, but they're shy. But this is expected out of the technology that will get more and more sophisticated. So, yeah, perhaps semantics.
Perfect. Enrico, something to add?
No, well, I would say that at the moment, we are more confident on applying these AI bots on maintenance issues, on documentation, not really on process, not yet. We don't trust it for the time being.
Okay. There's one here addressed to you, Thiago, about the relationship and the partnership with startups in the new technology development. If SMS works on that, and maybe Enrico and Kurt can comment also from Prime Metals and Daniele.
Okay, that's a good question. Yeah, we have a network of startups with whom we work, develop together in several aspects. Sometimes they bring in new process technologies. We have startups in the metallurgical arena with new process models and so on. We have startups on the digital arena. But the reason I'm here today is testament to this. I came from a startup that was acquired by SMS. So SMS has a large strategy related to partnering with other companies and also investing in M&A. So, but this is an important branch of innovation. So in addition to the traditional channels with universities, research institutes, and so on, to leverage the innovation that is coming from startups. And I insist, not only digital. We have several in flat processing area, in metallurgy processes that are ongoing today.
We work with startups as well, but when it comes to software we deliver to our customers, there is requirements from the customer sides, and we put these requirements to ourselves as well. When it comes to robustness, quality of the software, when it comes to cybersecurity aspects, and when it comes to maintainability of the software. If you buy software from one of the plant builders, the equipment is designed to last for, I don't know, let's say decades. Software usually is not designed to run for decades, and in fact it does not, but it should at least be maintainable for the next 7, 10 years, something like that, and even if it's 5 years. And we as a supplier have to ensure that we can maintain and service the software for our customers. And with cybersecurity demands on top, it's not only our, let's say, our intention to have a service contract, there is a legal obligation to maintain the software. And startups can bring in great ideas, can bring in new technologies, that's all fine. But when it comes to software we deliver to our customers, we say, guys, great idea, thank you. And then we implement it on our own with our experts to make sure that we supply robust, maintainable, long-lasting software.
Just one, adding, obviously startups are part of, let's say, the digital transformation. We need to use the best of breed sometimes, especially for applications, for specific applications, which are not probably the core of our technology. So an example, we just before coming to this panel, I saw a presentation where we were actually showing a cooperation with a startup on a let's say, virtual reality environment for training for the operators. This is a perfect example of where startups can be applied.
Okay, thank you. All of you mentioned in your presentations the human aspect of this transformation. And what do you think that will be the role of humans, of the workforce in the future? And do you believe that we are prepared for that, for this chance, or being prepared?
Well, I think that this is, the answer is yes, we are prepared, especially the new generations are very much prepared for that. When in the example of the pulpit I was showing before in ABS, actually we are employing very young guys, and they can very easily work in the new environment. Maybe it's more difficult to use the old operators with this technology. So I think especially the new generations are very much prepared for that.
The role of the people will change, yes, definitely. And as I said in my presentation, it is more from making decisions to defining how the decisions are made. So the through process quality control system I showed, we see that the task of a quality engineer that formerly was doing grading and releasing the product for the next production step or for shipment to the customer, he's not working on one coil now. He's analyzing the data and saying, okay, this is the rule, these are the factors we need to consider, and if these are in the tolerance, we can go to the next production step or we can ship. So he defines the decision. Previously, he was looking at the data of each and every coil and saying, good, bad, I don't know. His decision maybe was also depending on what he did last night. So not very consistent maybe. Now he defines a decision based on data analysis. And I think that this is the bigger change in many areas, saying, okay, it's not the individual decisions, it's not the individual actions, it's defining what needs to be done. The execution is automated.
From my side, of course, there's change. And some of it we don't even know what will be. But I think, and I agree, the new generations are much better at adapting. So I think new challenges will come. They will have to adapt. But just to illustrate with perhaps one challenge, today I showed a few thoughts on the impact of AI and how the same people can become so much more proficient, more productive using AI. Okay, that assumes that that person had the other experience before. They had been trained before. They knew how to do it another way. And then with AI, they become extremely productive. Fast forward a few generations, you're looking at an extreme dependence on the AI, which can be okay for some things, not so okay for others. So the challenge will be, okay, so how do I keep my people capable of overseeing, capable of maintaining critical thinking, not overly reliant on the technology, even if they have been using this for the rest of their lives. This is perhaps the history of technology adoption in our scope. But yeah, we will have a lot of fun in the next few decades.
And still in this topic, what do you think about the upskilling and the reskilling of the workforce? How do you think that we need to care about that?
Upskilling the workforce. Well, actually, we have one big task and a difficult task. As a plant suppliers, we have the issue of being able to be let's say, to be aligned to the new technologies which are always and quickly evolving. So this is really becoming difficult, not easy, as it will be difficult and not easy for the producers to increase the level of their personnel, because also producers will, steel makers, I mean, they will need people with a different level of competence, a different level of, I mean, the operators will not be anymore guys looking at the strip and pushing buttons to, based on their experience, deciding what to do, but they will have to become really engineers, understanding what is happening and understanding how to interact with the automation system. So a different perspective and a different way of operating, which will require certainly training of the personnel and an increase of the average level.
Yeah, I mean, those statements fit together quite well. What will happen if the experienced operators are not there any longer? So no push button, no joystick, all automatic. Where do those guys gain the experience? If something is not working properly, they say, stop, I'll take over. Yeah? And the solution, or one answer to that, can be digital solutions. And there was a presentation of a colleague of mine, what we did on again, blast furnace in Brazil, building a training simulator, saying, okay, there is a high degree of automation. There is no big chances to collect experience, because automation solves almost all of the situations. If automation does not, the situation typically is very critical. So it needs this experience to intervene then and fix the problem manually. And the way out there clearly is training simulators saying, okay, you as an operator, maybe once a year or not even have the chance to shut down or start up a blast furnace, because this doesn't happen regularly. But you have to be able to do it. So go to the training simulator once a year, once half a year, go through these scenarios, learn what to do, and then we can keep a certain level of know-how and upskill the people to live in the highly automated world, but still be able to manually intervene. But for sure, this will not solve all the problems, but it can be a big contribution.
Yeah, which is a little bit how other industries have solved this already. But just upskilling is the only way to go, and it'll be unavoidable and necessary. But just a provocation to inspire the thought. 50 years ago, 1975. I don't have the numbers off the top of my head, but I got curious now. How many people did we employ in a steel mill? How many people per ton, if you want to do the calculation in a way? There were loads of people compared to today. So fast forward another 50 years. Naturally, there'll be far fewer people, and those that stay will have to be much, much more skilled at the whole thing. So the profile of the work is definitely going to change. So that's what I mentioned. Gradually, not overnight, but steady. It's not going to stop.
And Kurt, one question here. You mentioned a lot the importance of data quality. So the first thing first, as you just said. What do you think that is the big challenge on this topic? It's regarding governance, the correct understanding about the importance of the quality of data. or obsolescence of the systems? What do you think?
There is several aspects. There is a huge diversity of automation systems. They store data or they provide data in different structures which are ideal for the task of the automation system, but maybe not ideal for data analysis. Data recording typically happens in time series. If I want to analyze the data of a slab, time series is not relevant. I have to contextualize the data. So this part of the time series belongs to this slab. And all these kind of things, so that we provide a databases that is provides data for future use. And future use can mean data analytics, can mean business intelligence. The bad thing is, if I want to use business intelligence, I need different data structures than if I do data analytics. And all that is work that needs to be done. Needs people that understand the meaning of the data, which is not a big problem, because on both sides, the plant builders and the steel producers, there is people who understand the data. It's just work that needs to be done. And it's not a quick win there. That doesn't mean that you have to do everything at once. You can start gradually, step by step, to come to quick wins. But you have to have a clear picture where the journey goes. And not just pick 17 data points from somewhere, do a nice use case and say, look what I've done. This works, but it's not maintainable, it's not sustainable. This is what startups do. If you want to have a robust, maintainable solution, you have to have clarity on what you do with your data. You don't have to roll it out over the entire production chain, but you have to have a clear picture. This is how I want to deal with my data. And it's not sufficient to dump each and every database into one big data lake. Maybe necessary, but it's not sufficient.
Thank you, Kurt. Thiago, would you like to complement?
Yeah, I'm with Kurt. I've seen several customers investing in a data lake, which is nice. We sell one. I think you guys probably sell one too. But to me, the question of enabling all this data, connecting to all the data sources, doing the data cleansing and all of this is just the first step. And then what, right? So if you do this pulled by demand, it makes the returns far faster, the risks far lower, and the whole thing far more pragmatic. There are companies, perhaps there are even countries, people like to invest in a lot of infrastructure without necessarily knowing what that's going to be used for. I think it's valid for data because it's the new oil, right? It's fine. But there's also another way to do this, again, pulled by concrete demand. And you don't, I think the short answer, you don't have to wait to monetize your investment on data. You can do this right from the start.
Good.
Not much to add, I think.
Amazing. Enrico, the point here is regarding the contest, the challenge moment around the world for the industry, and how open the discussion to investments and choose the right ones in this direction of the innovation and digitalization and the high productivity, as you show us.
Well, I think the scenario has changed dramatically. When we started speaking of digitalization maybe 10 years ago, everybody was very excited, but basically nobody was really investing in it. I mean, there were a lot of ideas, a lot of initiatives, but I would say very limited investments. At the end of the day, things have changed a lot. I mean, today, whenever we receive a request for quotation, the digital part is intrinsic part of that. I mean, and sometimes is the is where we spend more time discussing and with the customers what we are proposing, which is our solution, how we intend to apply it, and similarly for revamping of existing plants. I can see that in the past we were proposing digital solutions. Today customers are asking for it. So the scenario, my opinion, has changed a lot, and it's quite, at least in our experience, is quite evident. I don't know if.
Yeah, I think that as we are sitting here representing 3 of the big plant builders, we've done a reasonably good job in bringing things back to the ground again. Going to conferences on digitalization of the steel industry 7, 8, 9 years back, there were data analytics companies who said, give me your data, I'll solve your problems. And I don't know if all the steel producers were believing that. Some were, and some were just scared because they were uncertain what to do. And now we are back in a situation saying, okay, and this is what I mean when I say we did a good job. We were confronted that, we analyzed that and we said, okay, this is reasonable for this industry. And this is what I see now. And I mean, this is not a very controversial discussion. Why? Because we have a lot of international experiences with lots of projects, and our statements here, what we say is very much what we see that is feasible. I agree with Enrico. In the meanwhile, this picture that has been transformed from a hyped picture that everything is possible has brought to a picture saying, okay, this is what is feasible, this is what can be done. Also, this is the right order to do things. And now we see on the market that we don't have to push those things that much into the market, because steel producers start to say, okay, this is what the industry is doing, this is what I want on my next plant, on my next project, in my next upgrade. And this is, I would say, the good news is that means that the benefits of digitalization will materialize. So we could say the harvest starts.
I can illustrate with a couple of points. First, we have RFPs for new plants every once in a while. Digital's part of the game. It's not an option anymore. So it comes as one of the packages. The owner, the company may choose to buy it together, may choose to separate in a package, as they sometimes choose to separate the services package, but it's part of the game. There's no question there. No one is going to buy a modern plant without having that thought through, or even buy, if you choose to split the packages, they're not going to buy our automation systems unless it's completely ready to be connected to everything else. That's one point. The other point is, again, when we're answering an RFP like this, it's common that you want to show your technologies, right? So customers are asking. So I want to go see that new rolling technology that you built somewhere. So where do I have to fly to? Same thing. I want to go see that digital system that you're selling here. We used to show up just with PowerPoints in the past. Not anymore. Now we have to go and showcase what's actually working, how it's working. And so it's part of the game.
It's clear. Thank you. Thank you. We almost finished. Maybe some final considerations, final comments?
Look, I end, sorry, from where I started. Yesterday we spoke of the difficult times, we spoke of China, we spoke of the challenges. Also, this is, also in digitalization, there is a clear perception that China is already going ahead in that direction. Now we don't know exactly how much is, let's say, show up, how much is real. What I know is that I've personally being asked by my major steel makers, visiting Chinese plant and say, we saw that in that plant, we saw that, why don't we do the same thing here in our plants in Europe, in Brazil, in whatever. So I think there is a new urgency in the market, in the steel makers, to understand to which extent this new digitalization is needed and which is the actual benefit that can be brought by some of the things we see in the Chinese plants, to be clear. I mean, the big pulpit with all the information, is this really advanced technology? We have an opinion on that. Sometimes we share that. Having a single room full of screens, is this a step ahead? Maybe not. We have a different view, which we presented today. We believe that we need to work with another perspective. We don't want to have a showroom. We want to have something which is bringing benefit, money to the steel makers and to facilitate their life. But again, China and what is happening in China is pushing also our markets to an evolution in any case.
I was in the panel discussion in the audience yesterday, hearing all those complaints, how terrible the situation is. And I think you told me that currently the production capacities in Brazil are utilized by 70% only. That means that there is huge capital investments out there that do not make money. And that needs a transformation. I think that it needs a transformation, competition country-wise. China, Enrico already said. In India, what I see recently, they are jumping on this digitalization train heavily. So they will be very competitive soon. And now there is these huge investments out there. And I mean, if you take a major plant, what's the share of cost for digitalization? What's the difference between a manually operated, let's say, continuous casting machine and a more or less autonomously automated casting machine? Higher productivity, higher quality. The difference in investment, it's in the percent range, low percent range. And as we said, we can not only work on new plants, we can upgrade brownfield projects. We can make those plants more efficient, produce better quality. We can support in transforming invested capital that is not making money into invested capital that is making money. But complaining is not the way to go. The way to go is just do it.
As Thiago said, it's part of the game, so digital transformation is the part of the solution of the competitiveness equation. It's perfect. Thiago?
And that would be my final thoughts. When I come to Brazil, talk about digitalization. So first, a disclaimer, I am a Brazilian native, so my opinion is admittedly completely biased. When I see the quality of the work that is being done here, that is presented here at ABM, on the rooms, posters, it's very high quality on the digitalization level. So the applications are nice, the applications of AI, the type of modeling, this combination of process know-how with the advanced mathematics, the technology know-how. Here, we operate at a very high level globally, very high level, at the top. So it's a testament to the people that we have here, the talents, to the companies that are part of the ecosystem that supply, and also to the steel makers that, believe me, invest more. Perhaps it's part of the way that we do things here to extract the most performance out of the existing plants, but invest and collect the results. So we here are operating at a very high level, which is kudos to the ecosystem. Difficult to sustain. We see a lot of investments coming from China, from Far East. They are trying to pull ahead, but we still have a shot at continuing at the top.
Thank you, guys. Thank you very much. Was really insightful. Muito obrigado, pessoal. Muito obrigado.
Muito obrigada, excelente debate. Muito obrigada, Wilson Rodrigues, pela moderação da plenária, pela condução. Obrigada mais uma vez, Henrico, Kurt, Thiago. Realmente tivemos aí um debate valioso com muitos insights. Antes do meu recado final, foram encontrados 2 cartões de banco da Kelly Aguiar e da Milena Rodrigues. Não sei se elas estão por aqui. Se alguém as conhece, por favor, os cartões estão guardados na secretaria. Muito obrigada a vocês pela presença, pela atenção, pelas perguntas que enriqueceram o debate. Estão todos convidados para o nosso coquetel de networking oferecido pela SMS Group. A nossa programação continua amanhã a partir das 8h30 da manhã. Tenham todos uma excelente noite.